Okay, so far we've looked at maths for integers and maths for doubles or maths for real numbers. And so for example, with the real numbers, we've got real numbers all on the right hand side, or doubles all on the right hand side and a double on the left. Now if we want to mix up integers and doubles, then there's a particular way we need to do it, and that's called casting. So for example, if we say want to have mass is equal to let's just copy this expression. We have lots of bodies all with the same energy and velocity. Then we might want to say we've got n1 times that. We can't just write that because n1 is of the type integer, and what we have to do is put in front of it double like that. And what that will do is convert n1 from an integer into a double, so it then does the equation properly. Okay, so I'll take out that expression and let's see what that gives us. Okay, so previously we had the mass coming out as about 2, and now it's coming out as about 30, which is what we expect because n1 is 15. By contrast, let's see, let's put something else in here. Let's say n3 is equal to integer of mass. What we're doing here in this expression, I mean, I could put a whole load of maths over on this side, but what I want to do is convert mass. We can see here that it's 30.6122. We want to convert that into an integer and call it, and put it into the value of n3. So what we can say here is calculated integer mass, and of course we're just using n3 for that, equals, of course, percent d again for an integer. Anyway, have a think what would you say the answer would be if we've got 30.6 there for the mass. Now we're going to convert it into an integer. What would you convert it to? Anyway, let's see what the computer does. We will run it again. Okay, so we've done that. It's calculated an integer mass. It's given us a sensible integer number, and that integer number is 30. Okay, so the way that a computer calculates an integer from a double is simply to remove the decimal places. So what it's done is just remove these decimal places here. Now, normally, if we think about making things integers, we normally think about rounding and rounding up or rounding down. And normally we look to see whether things are closer to or less closer to the number above or the number below. Now here we can get around that. We can make the computer do the same thing if we say it's for mass plus 0.5. Okay, so that means if the mass is, say, 30.5 or higher, then the number inside the brackets is going to become 31 point something, up to 34.999 or something. But if the number is less than 30.5, then it will still stay at 30, because 30 even 30.999, you put it in, and when you take the integer, you're just going to get 30. So let's try that. Let's see what we can do. So Control Enter. Okay, so now it's given us the sort of correct rounding it up to 31, and it's also again, of course, converted it into an integer for us. I'm just wondering what we can do. I want to show you. Let's see if we make let's make this n minus 4. So n is 15. So n1 is 15 minus 4 is n1 is 11. Just see what happens there. So calculated mass now is 22.449, and the calculated integer mass is 22. So what I've sort of shown with that test is that by using this expression here of mass plus 0.5 and integer, although that makes it 22.949, the computer still rounds it down to 22. And you can test it with other values, but that in fact should always work. Okay, so that's a little bit about how we can use both integers and doubles in the same calculation. We have to think very carefully about whether we're calculating a double here for mass or an integer here for n3, and then here where we have a double on the right hand side, we need to cast it as an integer with this expression. Or here we've got these things which are all doubles on the right hand side, but on this is an integer, so we need to cast it as a double with that. Okay.